One thing I want to very specifically make sure we get written in our plan book is not up on the homework board. It's up on the smart board only. You may put this in today's box or in your to-do list because it is a longer, term assignment than just like, hey, do this tonight, because you might not be ready to do this tonight. In the Schoology page, we have those homework feedback forms, the online one. This week, we will probably only be doing the 3 homeworks that you see up there and likely some questions from the closure. Notice today is Tuesday. Don't write down Wednesday. Today is Tuesday. I put them both up there just so you're aware. So check this out. In Schoology, I just posted this message that the Accelerated 7 kids have been kicked off this page. Not because they misbehaved, but I made them a separate page. So, our updates page, where you land when you come into my Schoology page, this can be used to ask homework questions. This was a misconception last year, you can post right here, right? You can do whatever and post it. You have the same posting abilities as I did. Now, I have the ability to delete your post if I feel that it is inappropriate or unnecessary, but say you're working on tonight's homework, and you're working on problem 108, and you can't figure it out. You could come on here and say, hey, use some capitalization, try to be a little bit copsy. On 108, how do, check it for spelling, and you could pose a question to your classmates. Your classmates can then, and you would want to actually pose a question, don't just say, how do you? Your classmates can comment back to you. If you are so courageous to post on here that you need help with something, that probably means your classmates also need help with it, at least some of them. Or if you are so courageous to offer up your assistance to somebody who needs help, so either you ask for help or you offer assistance to those that need help, I will offer up prizes for that. Not necessarily just candy, also stuff from the giant prize box from the Khan Academy Summer Smarties. Because I want to encourage you guys helping each other on your homeworks. Beyond that, you guys being able to post here and ask questions. On the materials page, I need your eyes up here. I see some people, I'm losing you. I've edited a couple things here. This bothers me. When you zoom out, those line up straight across. But I've edited things so the links that were just posted here just by themselves are now in this folder. If you click the little arrow by the folder, it shows you what's inside of it. Or if you click on the folder, you go into it. So there's those links, the student ebook, the homework help, and my YouTube channel. Here is where the feedback forms are, the feedback assignments. The first one I made ungraded. So this one is ungraded. You will not need to do this. But this one, you'll notice when you're in Schoology, pops up over here in your upcoming. It is actually due Sunday evening. If you do not do this, it will be a missing grade in Schoology. Are there questions about this actually being required this week? Because I know that on Monday next week, someone's going to come to me, what do I have missing? None of that. Hear me when I say this. You need to do this week. Same directions we talked about last week. If it's all good, and a couple people filled out the other one last week, even though you didn't have to. If you're all good, it's all good. But then when I checked your math journal, if your assignment's not done, you lied to my face, and that's an issue. If you have problems, if you have issues, if you have things you can't solve, this is not public. The feedback assignment is not public. So when you don't do the wrong one, by the way, notice the dates. So we are November 6th and November 10th this week. I'm leaving this here so people can check their old homework if they want. But this is the one you want to do. It is private. Your results get sent directly to me. Do not lie to me. I just need feedback. This is not like, did you get the homework done or not? It's, do you need help? I want to be able to help you if you need help. Any questions with that or the modifications that we've made to the Schoology page? Yeah, Grant.
You guys already gone over this, but will there be any homework Thursday or Friday?
Thursday, we'll probably do some closure problems, but we'll likely start those in class. Friday, there will not be homework. We are taking an assessment. We're at least starting an assessment. So we'll probably make it a multi-day assessment, but I don't like Friday homework, so I try to put assessments on Friday so we don't have homework, so we don't have anything new. Today, we are in 3.3.2. So if you want to go ahead and get out something for your notes and give it a header. So today we're going to review and practice working with decimals. Yesterday we were dealing a lot with fractions. Today we're going to play with some decimals. So while we usually use a calculator, we need to understand how division works. We talked about this yesterday, right? Division is either dividing into groups of a certain size or dividing into a certain number of groups. So when we encounter problems that involve both decimals and variables, we want to be able to simplify these expressions and manipulate efficiently. Today's problems are going to help us make sense of that. So you may use your calculator only to check. Those of you that have your personal calculators, we are only using those to check. So I'm going to zoom in here. I'll drag this down too to get us started. A book would be helpful to be in front of you, but if you do not, you can look up here. So Mr. Garcia needs to cut short pieces out of a 16-foot long board. All right, so that's what we're starting with, right? 16-foot long board. To use as spacers of his new house. These pieces must be 9 inches long. Be careful. Feet, inches. Careful. Without using a calculator, how can we determine how many spacers he could cut? So we have 16 feet to start. Each spacer is going to be 9 inches. Talk with your group about how we can approach this. So we have 16 feet. We need 9-inch spacers. Spacers are like things you put in between to make a gap, to make a certain size gap. Work this out. What do you guys think? I'll give you 2 minutes probably. Not 10, it's 11, so. Date and lesson number should always be in our notes. Date and lesson number. So if you don't have it, jot it down real quick. 11.7, 3.3.2. About 30 seconds, we'll come back to it. I think a lot of us figured out how to approach this. Aubrey, can I straight up do the division with the numbers that we've been given? Why not? That's actually not the reason. I could try with the 9 and the 16. It's going to give me a weird answer. What else is problematic about these two values? Ah, my labels do not match. How can I fix that? Huzzah. How do I do that? Figure out inches and 16 feet. Annika? 16 times 12, because my conversion factor here, we know that there are more inches than feet. My number needs to get bigger. I will multiply. So we multiply this by 12. Break it up if you don't know it. I can do 16 times 10, real easy. And this is what I do in my head literally every day. If I have to multiply, I have to break it up. I'm not good at multiplication, guys. Like, Real talk, I'm not good at it. I've just developed a strategy. Then I can do 2 times the 16. What's that? 32. So together I get 192. Is that correct? Can I have verification? Yes. So then we can try to divide that by 9. Because now our units match, right? Because that's inches and inches. What number close to 192 would be easy to divide by 9? Liam? Ooh, no, not quite. That would be easier than 192. You know, or okay, you're going to know it now. Aubrey? I mean, we could, but 200 is actually not any easier, really, because it's not, 200 is not directly divisible by 9. Think about the multiples of 9. I mean, we could, but especially if we go over the number we start with, it makes it kind of tricky. Just 1. Think about the multiples of 9. 9, 18. So if I think about 192 and I break it up into 180 and 12, right? That's still 192. What's 18 divided by 9? So then put the 0 on. Guys, I'm trying to give you strategies to make your life easier. Then we can do 12 divided by 9, which is going to give us, well, I could stack it like we did yesterday, 12 over 9. All right, 1 and the remainder. How many are left after I take 9 from 12? 3/9, which I can reduce into a third. So I get 21 and 1/3. Now that's not the only way to do this. So please make sure you have some work supporting that on your paper. But look at number 99 and try to make sense of what Sloan has done there. Sloan loves fractions. I'll give you another couple minutes to work on this with your team. Check out 99. You know, we need more time to get this copied down at my school. Little trick here. Sorry, then I'll let you work. The book can easily change font size. Notice their complex fraction 16 over 3/4. They just changed the font size. We can't do that as easily. So when working with a complex fraction, if I want to say 16 is the only thing in the numerator and the fraction is in the denominator, notice my flat fraction bar is the main fraction bar. Then I use a diagonal fraction bar down here. You don't have to. You could also write this as 16 over 3 and just do it like that, make it smaller, whatever you want. You gotta make some kind of visual notification. The 16 is the numerator, the 3/4 is in the denominator. So however you show that on your paper. Then Sloan takes it to the decimal, and that's easier to show because we don't have to change size or anything. So try this out with your team, talk about how we can do it. Sloan says he can use a giant 1 to help solve this problem. Interesting. I don't like complex fractions. Actually, that's not true. It's not that I don't like them. They're just complicated. Complex fractions is actually the nice way to say complicated. Serious. They named it complex because they didn't want to say complicated. But what they mean is it's a complicated fraction because it's a fraction inception. Did we talk about this yesterday?
Yeah.
Fractions inside of fractions make things weird. Right? We have we can talk about 3/8 of a pizza divided by, we can do all these awkward things. But here, we have an integer entire number divided by a fraction. I don't like that. I'd rather have an integer divided by an integer, right? Numbers are easier to work with than fractions, like whole values, entire numbers. How can I stop or undo, or however you want to think about it, the denominator from being a fraction? What giant one can I utilize to make this happen? Delaney, any thoughts? What's the denominator divided by? The denominator. What is it divided by? 100. So if I want to stop it from being a fraction, stop the division, which we can't really stop it, we can undo it. How do I undo division? Multiply it. So if I want to stop the division of 100 or undo the division of 100, I could multiply by 100, because that's what I want to stop from dividing. So guys, please on your paper show, we're going to multiply by 100 on the bottom and 100 on the top. What this does is stop this from happening. Now our fraction is no longer complex, and this is a giant one in case you want to notate that. It's a really fat one. That now makes my fraction. Anyone tell me? Anyone figure out what's my new numerator? What's my new numerator? 16 times 100. Patrick? Yeah. Not a trick question. Just work through the top. 16 times 100. My denominator. It's just 75. We effectively stopped this from happening. So when I have this division of 100 and this multiplication of 100, they undo each other. It's like if I say I'm going to double your pay and then half it. Well, okay, then nothing changes. So we divided by 100, then multiplied by 100. They undo each other, and we just get 75. We can turn a complex or complicated fraction into a simpler fraction by multiplying by the denominator. Now, there's yet another way to do this that we're going to investigate as we go through the lesson. But then here, I could probably simplify finding some common factors or things we can divide by. What could 75 and 1600 both divide by? I want to just simplify it. Yeah. Bigger. Bigger. Because 10 doesn't actually work very well for 75. That doesn't work for 75. Patrick? Or Nathan? All right. Your hand's up too. I know the two of you. You're just both up. What'd you say it louder? 25. Now notice they don't simplify, but I just want to make sure that we're thinking about this. I can cut 75 down by 25, and because this ends in 100, I know it can also be divided by 25. This will give me, obviously, 3 in the denominator. How many 25s in each 100? 4. So what we really have is 4 times 16. I think it's 64. Somebody can check that for me if you want. This is much easier to work with. From here, What number close to 64 is nicely divisible by 3? Alex? 60. How many 3's in 60? There's 10 3's in 30. 20. Then how many 3's fit into 4? One more. So we've split up the 64 into 60 and 3 and the 1 extra. All of these have to be divided by 3. 60 divided by 3 gave me 20. 3 divided by 3 gave me 1. And I have a remainder left over when I divide by 3 of a third. So we get 21 and 1/3. Now this can be done with decimals, because really everything we just did is fractions. So look at parts B and C for just a second. Look at it on your own and see if you can figure out what exactly they're showing you there. Really, this question right here. So what that question is asking is this 1,600 divided by 75 the same as this? Are these that I highlighted in yellow the same? Talk with your team. Anyone have strong opinions on this? Whether they're the same or not? Let's see. What do you think, Dominic? Are they the same? No? Patrick, what do you think? Are they the same? Ooh, we have a yes and a no. Any tiebreaker? You think it is? Why? It's the giant 1. Compare the fractions. Numerator gets 100 times the original. Denominator gets 100 times the original. Now, if we look at the long division, this would suck. Like, we're just being honest. Dividing with a decimal number is like, gross. What I want you to see, because this is even easier than the giant 1. Give me your eyes for a second. If I want to bump this decimal, I can. I can do anything I want, as long as I follow the math rules. What's the math rule about if I do something on the bottom? We do it to the top. So if I do it there, I also, there's my decimal, have to do it here. I do it again, which means I have to do it again. And I end up with decimals in nice locations. Which even once we get here, I can do the same thing. If I bump this decimal 2 places, that's multiplication by 100. So I do the same thing here. I have to put zeros on it, but I get 1,600 inside. So that's how this becomes 1,600 divided by 75, which is much easier to divide. Because I can just work 0, 0, and then work 160, which is very close to 150. And we work it from there. Questions? these are the techniques that make all of this much easier. If this doesn't make sense while we continue to practice it, please ask a question, because we want you to be comfortable with this when it comes to your practice. And our note, we just essentially discussed this. So please, if you can, show this out in your notes. I'll give you a minute or so to get this copied down. Show the fact that we can move the decimal either in a fraction or in a long division, as long as we do it to both pieces. So either write yourself a note or show a picture of it, whatever you want to do, so you can remember we are allowed to do this if we do it to both. Then look at 100 and see if you can solve it more easily than how it's set up. Try 100 with your team.
The title of your book is Dog Man Unleashed. Unleashed.
Everyone get here? Copy this down. Difficult. So, Patrick, I'm skipping your card. We've spoken a lot today. Hi. Renard, what could I do to both of these values to make this easier to deal with? Move the decimal where? How far? Thank you. I'm kind of picking on you because we haven't formalized this, but when you speak about what we're doing mathematically, we need to be very specific. So Renard said, move the decimal. I knew what she wanted me to do, but I said, what direction? She said, right. And then how far? One place. Because I can do anything I want to do. I could move it left if I want. I could move it 100 places if I want. But I got to do it to both. So I move this decimal to the right, this decimal to the right, and our division problem turns into 160 divided by 5. How many 5s fit into 16? What does shout it out? 3. 3. Remainder of 1. How many 5s fit into 10? 2. Hey, look at how easy that was. That 32 is the actual answer here. The decimal location that we moved doesn't matter. The misconception people normally tell me is, oh, I moved our decimals right to get here. I now have to move my decimal back. That's not true at all. This problem's the same problem as this. The answers are the exact same. There's no difference in the answers. Are we clear about that? We do not move the decimal in our answer. Now, 101 says use your calculator. I think we can do it without, but whatever you want, use your calculator or not. Up to you. Work on that with your team. Take a couple minutes. may use a calculator if you want. I just know some of us probably don't need to, but you may if you want. I also don't like the long division symbol, so I avoid it whenever possible. Please make sure you have all these written down, even if you don't have answers. Just make sure that you have these written down, please. There's a lot to do here. Give you another minute. Felt that judgment. Feels like, oh, dude. No, without that center. So what it should be. This should wrap the other direction. We're gonna random card for all of these. Question about the fact that I said I'm going to random card these? Miss Brown, for 3/4, is there any decimal shifting that I need to do? What do you want me to do to 3/4? Okay, to make it 30 over 40. Okay, then what do you do? Okay, so then I don't like the long division symbol, but I could do this. I could have actually done that with the 3 and the 4. This is also one that we might just kind of start to memorize. Do you know how much 3/4 is worth? Yeah, 0.75. 75 cents if we're talking money. But that's one that we should try to get into our memory so that we don't have to do the division. Yeah. 30 over 40, but yes. Yeah. So, Allie identified we have the same problem. If I just modify A, it's the same as D. So she knows if I modify A slightly and make it match, I'm going to get the same answer. Good investigation. I like that. In B, you have a question? Then I'm not calling on you. I'm sorry. Eleanor, come back. All right, Liam, you're here. Do I need to do any decimal shifting?
Yeah.
What do I need to do?
Well, for 1.5, the decimal 3 times.
Now,
To the right.
what made you decide that? The numerator or the denominator?
The
Denominator needs 2 decimal shifts, so the numerator has to take 2, even though it doesn't need it. This now becomes, please make sure you're writing this workout, because trust me, it will make your homework so much faster to understand this. What does my numerator become, Liam? 150 over, how much easier is that to solve? How many 25s and 150s? 6. It's the same thing. It's just way easier to think about. Right? Take away the decimals, our thought process gets simpler. In C, Monica, I'll actually call her. I was going to skip your card, but break your heart. How far do I move my decimal in what direction for C? 1 to the right. Got to do it to both. So, wait. Oh. The same?
Oh.
But they didn't start the same.
Yeah.
Notice this only needed 1 decimal shift. This
Oh.
needed 2. If we had just taken B and shifted it 1 decimal place, we would have gotten C. But to be more efficient, we went both decimal places, and we already know the answer to that is 6. Allie already told us the answer to D is the same as A. Emma Brown, what about E?
It's the same thing as doing 3 divided by 4.
How?
Just taking out the zeros.
Yeah, so more so we shift my decimal 3 places. If you care to know how this is happening, we're still applying the giant 1. We just don't have to formally write it. Here we multiply by 1,000 on top and bottom. That's how I get 3 over 4, which is just 0.75. Nathan in F. Sorry. How far do I shift the decimal? 3 times what direction? To the right. So boom, boom, boom. Boom, boom. I'm going to have to add a 0 here. And this becomes, oh, look. Another form of the same thing we already saw. Now, Alan.
Yeah.
This is a toughie.
Oh.
G. G has a trick that will let me solve it in the form as it is right now. Now, if you don't know exactly what we want to do right now, I'll give you one more hint. But do you know what we could do here to make this a much easier fraction? Because right now it's a super complex. Fractions in both parts. Super complex fraction.
We could make a giant 1.
Of what? What's our giant 1 going to be? What do the top and bottom need multiplied by to make our life easier?
What?
Undo the division. What is it dividing by? What's the numerator divided by? It's 3 divided by... Look at it. Numerator. Only look at the numerator. What's the numerator?
3.
Divided by... Remember, this whole thing is numerator right now.
I thought that. 3 divided by 2.
And what's happening in the denominator?
4 divided by 2.
So they're both... What's happening in both places? Division by...
10.
How do we undo that?
Multiply it.
There we go. So Alan identified, if we just multiply by 10, and if you want to think about it as a fraction, it's 10 over 1, we can make a super complex, super giant 1. Actually, it's really not super complex. We're just multiplying by 10 on the top and bottom. Hey guys, here's a secret. 3/10, 0.3. 4/10, 0.4. All we're doing here is moving our decimal. And we again get 0.75. And Grant, how far and what direction do I move my decimal in H?
To the right, and I think 4.
Correct. We go to the right, to the right, to the right, to the right. Top and bottom. 1, 2, 3. Who what?
The bottom denominator should have another 0.
Ah! Thank you, Patrick.
What?
I wrote this wrong. Good catch. That was not on purpose. The numerator is 0.0015. Denominator is 0.00025. So actually, my apologies, Mr. Curry. We move it 5 times, which on the numerator is actually going to create an extra 0 here, and this becomes 150 over 25, which we've already done. Is like 10,000 times. That's a hyperbole. Hold on, let me check what we did not get to and see what we think is going on.
I just realized. All the answers are either 0.75 or 6.
Does the technique that we're using make sense? And we have no need to finish the lesson. Marvin, what's up?
I just didn't understand like how you guys did.
So, check it out. So, if we look at a couple more. If we look at like 103, let's say B, if we had negative 1.12 divided by 0.7, we don't want any decimal places involved in the fraction. So, which one has more decimal places? The numerator needs to get rid of 2 of its decimal places, so we have to follow and do the same thing in the bottom. However, I need to put a 0 here since there's nothing in that space. Now this becomes 112 over 7D because my new decimal locations are here and here. We do that for every problem that needs the decimal moved.
Yeah, I understand that, but it's like the answer. You guys actually got the answer. I didn't understand how you guys.
A lot of those were just repeated answers. So as you're doing your practice today, if you're getting stuck, just use C, but we can use our calculator too. It's just easier to think of the integers, the numbers that don't have the decimal in it. So like the 112 and the 70, that's going to be easier to think about than 1.12 and 0.7. Those are just hard numbers to think about because they're really small. So it's just about making it easier to think. So come see me when you're working on your practice. We'll get you straightened out. But I think after you try it a couple times, it'll be okay. And Marvin, make sure you submit the homework feedback thing at some point this week to let me know if you're still having issues. Make it quick.